Alright, so the next example is a tougher example. It's got the cubes in it, and so I know I'm going to have to solve this by substitution, so it's just a little more complex. The steps are the same, though. I have to find my first order, find my critical values, find my first order derivatives, and set them equal to 0. Alright, so my first order derivative with respect to x is 3x squared minus 150y. Set it equal to 0. F sub y is 3x squared minus 150. 3y squared. Y squared minus 150x set equal to 0. Alright, so you'll notice both terms are very similar. And so this one's tough because you're going to have a square term you have to deal with. Right? Either way you go about it, you're going to have to square something. Right? So in this case, it really doesn't matter which equation you solve for first or which variable you solve for first. Alright, so I'm probably going to pick this equation and solve for my y. Alright, so that means I'm going to get 3x squared. I'm going to move my 150y to the other side by adding it. So I get a positive 150y. And I want to go the other way. I'm going to solve for y. 150. Alright, so if I simplify that, this reduces to 150x squared equals y. So again, it's not going to be pretty. That's what y equals. So I'm going to go up here, and I'm going to plug it in here for y. So again, I'm replacing y with 150 times x squared. And it's going inside here, and so I put parentheses because it's replacing this y, so it's going to be that term squared times a 3. So when I plug it in, I'm going to put parentheses around it. So I'm going to get 3 times parentheses 150x squared, parentheses, and then squared again. Alright, so this is the tough part. First thing I'm going to do is I'm going to square. Remember, everything gets squared. The 1 gets squared, the 50 gets squared, and the x squared gets squared. And so when I square everything out, well, 1 squared is 1. 50 squared comes out 2500. And x squared comes out x to the 4th. Still minus 150x equals 0. And then I'm going to just leave that fraction. Or you could reduce it if you wanted to. Alright, so I've got this ugly expression, right? I've got this fraction, x to the 4th minus 150x. But you still solve it by factoring. Both terms have at least one x value they share, right? I've got 4 x's in the first term and I've got 1 x in the second term. And so I can factor out a single x value. When I factor out a single x value on the first term, I'm left with 32500x cubed minus 150 equals 0. Alright, so I do have two factors. I've got the first factor x, which gives me x equals 0. Alright, so I've got an x equals 0 is a critical value. And then the second one's going to take me a little more work to do. I've got to isolate the cube and then take the cube root. Alright, so I'm going to move the 150 over. Alright, I add it to the other side. Change that to a 3 instead of, or 2 instead of a 3, and then multiply by that ugly fraction. Alright, but it actually simplifies nicely. I get x cubed on this side, that fraction's gone. 3 goes into 150, and then I multiply that out. So again, you can use your calculator. Alright, but it does come out to a nice number. It comes out 125,000. My last step is to take the square root, but actually on the calculator it's easier to use the fractional power, right? Raise it to the 1/3. And whatever I do to one side, I do to the other side. So here, I'm reduced down to just x. Here, I take that number, raise it to the 1/3 power, and that reduces down to 50. Alright, and so there are my two critical x values, alright? That's half the point. And then I have to plug them in here to find my y value. So my y value, remember, equals 150x squared. So when I plug 0 in, well, I still get y equals 0 out. When I plug 50 in, well, as it turns out, I get 50 out. That's why it really didn't matter which way I went, because it would give me the same thing if I had solved it the other way around. Alright, so I've got two critical points. I've got a critical point at 0, 0, and at 50, 50. Alright, now the testing, which I didn't give myself enough room to test. plenty of room there. Alright, so remember the D formula is XX times YY minus the mixed squared. Alright, so find those derivatives first and then plug them into the formula. Alright, so f sub xx, apparently I wanted to scroll up too far. There we go. Alright. So I'm looking here first. So with respect to x, it's going to give me a 6x. And then with respect to y, since I'm going to go ahead and just look, it's going to give me a negative 150. So I go ahead and write those down. So this gives me a 6x. This gives me a negative 150. And y, if you go look at it, it'll give you a 6y. It gives you the same thing out, but in the y direction. Alright, so my D formula is 6x times 6y minus a negative 150 squared. And so if I simplify that, that's 36x times y minus 150 squared comes out 22500. Alright, so there's my D expression. And now I test my points. Alright, so first I test 0, 0. When I plug the 0, 0 in, well that zeroes out, leaves me with that negative 2500 less than 0. And so that tells me 0, 0 is a saddle point. Alright, neither a max or a min, so I don't really need it. It's a critical value, but it's neither a max or min, so I kind of just, alright, it's critical, yay, alright, move on. Now I test the other point, which was 50-50. Alright, so I plug it in, I take 36 times 50 times another 50 minus the 22500. That comes out 67500. So that comes out positive, so that tells me it turns. So it checks that it turns, and then I see which direction it turns. So you can pick either one. Again, we typically pick the x-axis. Was 6x, so it's 6 times 50. Well, that's positive, so that means it turns up. Alright, so it turns and it turns up, so that means the point 50-50 gives me out a relative minimum. Right? If it turns up, it gives me out a relative minimum of, well, whatever f of 50 is. Alright, I have to go back to my original function and plug 50-50 into it. Alright, so I go back up here to the x cubed, y cubed, minus 150xy squared. Apparently I didn't find that yet. So 50 cubed. So 50 cubed plus another 50 cubed. Minus 150 times 50 times 50. Out negative 12500. Alright, would be the relative minimum. Alright, so that was the harder case where I have to solve by substitution because I had cubed terms in my original expression and I got two critical values out. So whenever you do the substitution case, typically you'll get more than one. That's the cases where you get multiple critical values. You either get 1, 2, 3, or 4, typically. For us, most of the times it's 2. One of them came out a minimum and one of them came out neither, a saddle point. Alright, so in this case we have a minimum at the negative 12500. Alright, we'll stop there. We'll do the next example, which is the hardest case with the exponential in my next video.